So welcome friends again to a session on Chai Coffee channel. So this time we have a very interesting guest which is known as Kubernetes, or fondly it is also called K8S. It's one of the popular technology tool set, whatever you want to call it, and we'll try to get to know it a little better in this session. Okay. So welcome on our behalf. I'm Samir, and I
Hi,
also
I'm
have with
Prasad.
me Prasad. Yeah. So welcome, Prasad.
Yeah, thanks.
So let's see. I think let's try to understand what really our guest does. How he does his magic. I think let's try to understand that. But basically, before we go there, right? I think let's try to see. I mean, if we roll back ourselves maybe 6, 7, 8 years back, right? And again, e-commerce has been there since long time. But there are a lot of e-commerce startup during that time, 7, 8 years back. Cloud was coming in. So these e-commerce guys, the startups, they used to always start with some small, POCs, POVs, technology of their choice. Rapidly, try to develop their applications, right, in whatever technology they have chosen, and sometimes host it on-prem, sometimes or most times try to choose the cloud of their choice, etc. Right, and that's what they used to do. I think you and I, both of us have faced this ourselves, and we have seen others do this
Yes, yes,
here
yes,
and
yes.
in Bay Area and all that. But I'm sure, and a lot of startups don't kick off, right? After a couple of years, they face problem. But a lot of them really kick off, right? And they just start scaling. Probably they wouldn't have imagined themselves, and a huge scale up happens, right? In terms of the usage, clicks, number of transactions, and whatnot. I'm sure in this kind of a business model, they would be facing a lot of challenges, right? This whole journey must be very complicated. What do you feel?
Yeah, absolutely, absolutely. As you have rightly said, like during the initial days, everything is fine. But when you start becoming more and more successful, then suddenly, tons of business challenges they start hitting you. And I think the biggest thing is once you are a successful startup, or once you have a let me say that once you have a successful business idea, let's say maybe something like an e-commerce site or something of that sort, then people expect you to keep on adding new features very, very, very fast. And if you don't add it, then it starts affecting your end users. So the biggest challenge which these successful companies they face is a need to fast to increase the speed of time to market. So they have to
Yeah.
have a faster time to market. So whatever innovations which they are doing, those innovations needs to be brought very fast to the market so that end users can get benefit out of it. Otherwise, what may happen is that end users may expect for some amount of time, and eventually they may even lose interest or may go to your competitor. So I think continuous innovation and then having those features implemented inside a product as fast as possible, I think that is a really a very, very, very big challenge at this stage. And then the next challenge is while implementing that, another thing is that your cost of the IT, like infrastructure, whether it's a cloud, whether it's a local hardware, software, like you have to use it in a very judicial manner. Otherwise, if it starts shooting, then it may affect your company's budgets as well.
It will burn all your
Absolutely,
funds, whatever
absolutely,
small funds you may
absolutely.
have. So
Yes, yes, yes. Yeah. So you have to bring it fast and also look at the cost very, very carefully. And then that doesn't mean that you should not spend money, but then you have to spend it in a very optimal manner. And that's a big business challenge actually. Yeah,
yeah. Right.
yeah. And
And
then
how do
uh,
they really cope up? Like, I mean, I always wonder 1 or 2 years, very, users come in trickle, and then suddenly there is, things go viral for some of them.
yeah,
That
yeah.
viralness, how do they manage basically? How do they scale their business?
Yeah, absolutely. In fact, the traditionally what companies used to do is whatever the infrastructure they have. Maybe
Mm,
let me take a simple example. Let's say I may have a couple of servers. So maybe one
mm,
web or application server and my database server. So traditionally, in a simplest manner, they used to simply increase the power of those server actually, and that way achieve the scalability whatever is required. But then that is not really going to work in an internet era, because suddenly your load may increase in a very, very fast manner, and then it will expect much bigger hardware as compared to just increasing RAM or maybe adding CPU cores and etc. So you have to increase the business scalability, but at the same time, you have to ensure that you are not really spending too much money on your capital expenditure. So that's really a big challenge. And then another thing is that probably sometimes it could be just a spurt. So maybe there is a 2020 match going on, and then you're suddenly the load may increase, and next day the load may not be as high as it was yesterday. So again, if you have invested heavily in infrastructure, and then maybe you are underutilizing the whole infrastructure. So that also one has to avoid. So that's another big business challenge. And then another issue is that when you start a company, then maybe you may invest a little bit, may go with a certain cloud provider. And eventually, as you keep on adding your team members, keep on adding features, or maybe you may even acquire a product, or you may even integrate some other product. And then it may result into hybrid or multi-cloud kind of a platform. And then managing all this complex infrastructure becomes another big business challenge.
Exactly. Yeah. I think handling just one couple of machines is easy, but when you know have like bunch of servers yourself and a bunch of them in one cloud and another cloud, I think that whole thing is complicated.
Absolutely, absolutely, yeah.
Yeah. So net in summary, when you say faster, I mean, rapidly going to the market or going to the market very fast also means my development process I have to adopt faster. I have to deploy faster, right? If I understand you correctly, right? Because I may develop, but I don't know how to deploy on these complex environment, then I'm in trouble. That's also is one of the, business challenge implies that essentially, right? And again, I don't have too much money, so I can't invest in bigger environments. I can't have large infrastructure teams. I will have probably a handful of people, or my own developers would be, doing the same job and stuff like that. And I mean, if I want to summarize, that's how it will look like, right? So yeah, I think that is interesting. But again, this we are talking about 7-8 years back. So I'm sure there must have been standard technological evolutions, revolutions, solutions, whatever, right? So if you want to name 2-3 things that happened during that time,
yeah, absolutely. Actually, in fact, absolutely, absolutely. As you have rightly said, these business challenges, they actually people came up with number of solutions to address these business challenges, and I must say in a very, very effective manner. So typically, just to name a few to address those challenges, if I have to list, then typically people moved their monolithic applications, like something which is like very tightly integrated into one large, very application block. They literally broke down that particular application into number of small services. So basically, they moved from a monolith to a microservices based application platform. So that itself addressed majority of their needs. Because the main thing what it addressed really is, now you don't have a very large application to manage. So even if you have to do a small change with a monolith, you have to bring down the whole application. Or maybe you have to, the build process itself may take a good amount of time, and deployment may further take a lot of time. So instead of that, now you have your application consists of number of microservices. So you can, and those microservices, they can have their own life cycle. So you can upgrade them independently. So this movement, like monolith to microservices, address some of the business challenges which we saw. And then for this architectural style movement, I think the biggest thing which helped is adoption of Docker and containerization. Because having a containerized kind of an application, it helped the organizations or architects to manage your applications in a much better manner. So you don't have to have dependencies on your host operating system or other applications which are running, and then that particular image can really run in an independent manner. So Docker containerization is another interesting solution which started addressing this business challenge. And then there were
portability across clouds also, right? So that you are not bound to or married to a cloud and cloud or on-prem.
Absolutely. So basically, you can have an image, a Docker image, and then maybe you can deploy it on AWS or Azure or maybe on your own server. So that gave that kind of a flexibility. And whatever is required for the application to run, that was containerized in that particular image. So that helped a lot to address the business challenges what we saw. And then another thing what we saw is because of the continuous innovations, you have to keep on adding different features. And if you have to keep on adding different features, then apart from the technology and architectural pattern, I think what is required is continuous integration and continuous deployment pipelines. So that way you can keep on hot deploying your application and reduce your development cycle and as well as deployment cycle. Because if, you may complete your feature, but ultimately if it is going to take time to deploy your application, then it is again not really going to help. So automated CI/CD pipelines also help to address all these business challenges which we saw. So just to quickly summarize, microservices, containerizations, and CI/CD, automated CI/CD pipelines. This really help to address those challenges.
Yeah. I mean, I remember a couple of funny incidences. Like, we all worked in product companies, right? So maybe 7, 8 years back, release of a product was like it's like today I have a release, which means once in a year or maybe once in 2 years, right? And that release also used to be, you are releasing a 4 gigabyte DVD. So, if customer orders a DVD, right? I think gone are those days, right? Whatever we are talking about.
Absolutely.
I mean, CI/CD, you rightly mentioned, right? Agility and CI/CD. Forget yearly release, forget quarterly release. We are now talking about weekly and daily pushes, right? A number of daily pushes. I mean, you have to reach. We have reached that level, and it's impossible without the things that you mentioned. So
absolutely. In fact, what I miss in this is, all those release parties, they are almost over because now release is almost every day or every hour. So you can't have a release party at the end of the quarter or whatever. So basically, then we have to just get our cup of coffee and do a release automatically. That's how it has reduced.
Exactly.
So that's the one thing which I'm missing really.
Correct.
Yeah.
So, but now if I look at what you said, right, all these three magical things, they must have solved all the problems, right? But did they really solve all the problems? What do you feel?
Yeah, actually, interestingly, like, typically we have seen that whenever there are challenges, then we come up with very innovative solutions. And then, like a circle of life, like those innovative solutions may come up with new challenges. So probably you may address your original challenges, but ultimately you change your orbit and then you end up with new challenges. In fact, that's what it happened. Like after adopting microservices, CI/CDs, and containerizations, then what really started happening is because of all this flexibility, is suddenly you have a very large number of containers as a part of your application, and that also spread across the data centers. Now you can imagine the challenges of a deployment engineer. Now you have fine, I have containers, but now if I have to deploy, then I have to deploy them across data centers, maybe across geographies. And then once a deployment is okay, but later on, just imagine if I have to make a certain change and deploy to only a certain part, then it's really a tough thing. Then I have to write scripts and then manage, use technologies which can help me to automate those parts. But still, managing those large number of containers is really, really challenging. And then with all this continuous and fast deployment, another challenge is, unfortunately, if something goes wrong, if I have to really roll back, then it's an absolute nightmare, because then I really don't know what has what has happened. So with this, because of this containerizations and
microservices and containerization, they bring dependency. No container works on its own. That's only a theory, right? There are dependencies and you have to manage them. So
absolutely. And then another challenge is like scaling up and scaling down the application, and that also in an automatic manner and in an optimal manner. This is the new challenge, because I may now suddenly my load is increasing, so I may invest into a hardware, but then probably next day, if the load is not as high as it was there yesterday, then my hardware is underutilized. So in that case, probably I should have some kind of a mechanism in which I should be able to not only scale down my application, but also reduce my cost. Now that is something which is very difficult to manage in a manual manner, or even with scripts. So this created a new challenge. Now here I'm not talking about 2, 3 kind of containers. Like typically for an e-commerce kind of application, maybe there may be at any point of the time, 400, 500 containers running, or maybe in thousands, Samir. So
absolutely 1,000 possible, because we have actually seen that happen in our products.
And then you can just imagine the kind of pressure which is there on deployment engineers. Like so many containers are running at across geographies. They are scaling up, scaling down, and then that's really a huge challenge for them.
Okay. Perfect. So I think even though we say there are these three magical things which happened, right? Containerization, which facilitated how to use cloud, and of course microservices to divide and conquer your application and deliver faster, and CI/CD pipeline. the challenges actually probably increase. I mean, some challenges were solved and new challenges were introduced, right? So
Absolutely.
effectively, if you see, we needed something, a tool set, a technology, or a platform which will allow you to manage, coordinate, or orchestrate, maybe that's the right word, hundreds of containers, thousands of containers, and all that, right? All these Docker containers. So even if you
Absolutely.
adopt
Absolutely.
Docker, you still have to manage this, roll it back, release in certain frequencies, and things like that. Is that
Absolutely.
where then our Mr. Kubernetes comes into picture?
Yeah, but just one more line, one more thing which I want to add is,
Hmm.
while these challenges were there were some solutions. Like for example, AWS had ECAS or Mesos
Correct.
were there, but then they were addressing these challenges at a different levels. But the main challenge here was that, like, once you use ECS, then it was like a proprietary AWS or Amazon technology. So once you sort of adopt it, then you are stuck with AWS. So fine, there was some solution, but then it was very much
That
specific
openness
to
and portability, I mean, that
absolutely,
was
absolutely,
definitely not
absolutely.
there. Yeah.
So that's where there was a need of a
Hmm.
different kind of a solution or a product to address this
Got it.
challenge.
Okay. And so that's where Kubernetes comes in, correct? So
Absolutely, absolutely.
tell us a bit about, introduce us to Kubernetes, the initial introduction for us.
Sure, 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 sure.
Yeah.
So typically, Kubernetes was, or it is also called as K8S. Actually, it came for the rescue for all these large enterprise or maybe internet-facing applications. So before really going into the details of Kubernetes and a bit of history of that, let me just quickly tell what really a Kubernetes is, or maybe a formal or a simple definition of Kubernetes. So basically, Kubernetes is nothing but an open source system. So first, most important, it's an open source system. And for what? It is for automating deployment of application. So deployment is automated. Scaling of application. So you have, for application scaling, it is used, and then management of containerized application. So you have an open source solution which can help you to automate your deployment, manage your scale, and manage all the containerized applications which you are running. So somebody who is going to take care of entire management of your application. In fact, what it really does is it basically tries to orchestrate, or maybe I can say that distribute the whole load across your different part of your infrastructure. So somebody who's a manager or an orchestrator. So that's where Kubernetes is all about. But most important thing is it's an open source system, and something which is not tied up to any of those vendors. So that's like a simple or a simple introduction of Kubernetes. I think as we move ahead, then we'll start understanding these points in more details. Now, before going into a little bit of history, like as we have seen, before even Kubernetes, AWS was way ahead in terms of other competitors. Like they were already having their own solution like ECS. And then a lot of people started looking at it, started, maybe some of them started using it. And then that motivated other people to go back to the drawing board, like how we can compete this ECS part. There are there are some other options available like Mesos, etc., but not as powerful or as famous as what ECS was there. And then people started working on different solutions. Like Red Hat was working on OpenShift. Google had its own internal orchestration system, what they call it as Borg. But then Google started thinking about having a new solution, a total new solution for their cloud platform, something which can address all these challenges. And then the whole idea was that it should be platform sort of an independent. And then this is where Google created Kubernetes 1.0. I think around 2014 they created it, and with a
That is the time
commitment
they.
to open source it. Absolutely. So almost about 8 years back, that's when the 1.0 was launched by Google. And then as they started working on it, people started evaluating that. And then other organizations like Red Hat, CoreOS, etc., they started joining hands with them. And then as Kubernetes started maturing in Google, a lot of interesting technologies they started adopting a lot of interesting technologies. Like for example, around 2016, there was a technology called as Helm charts. So it is nothing but a simple package manager for Kubernetes. So because all said and done, it's a very complex platform. So you have to have something very easy, or something which can be used in a very easy manner, so that you can instruct the Kubernetes to carry out a certain task. And that's where this Helm charts was really useful. So what it really does is it helps one to define, install, and upgrade the even complex Kubernetes applications. So something like a language which you can use to interact with Kubernetes. So it's nothing but a packaging format, but that helped a lot for further increasing the, what you can say, adoption of Kubernetes. And then by 2017, almost Kubernetes, if I don't know whether I can use this word, but whether Kubernetes almost won the war, and everyone, including
They surely
VMware.
did at that time, yeah.
Yeah, I
Yeah.
wanted to avoid the word war, but fine, yeah.
It was a war.
Uh,
But, yeah.
but yes, like we can say that, yeah, but they won really a war, or maybe competition, I can say. And then
Correct,
all
correct.
other people like VMware, then Cloud Foundry, Azure, AWS, everyone, then they announced their support for Kubernetes. And today it is most preferred container orchestration platform. And then what they also did is Google handed over that particular Kubernetes platform to CNCF, like Cloud Native Computing Foundation. So that showed their commitment. It's fine. They don't want to sort of have a proprietary ownership of it and let it be managed by a totally different foundation project. So that's how it was handed over to CNCF. And this is what a brief history. So almost like last, I think, 7-8 years, and now it has become almost like ubiquitous in this complex application deployments.
Even today, I think every cloud provider will have their own way of container management. ECS is still there in AWS and all that. But I think if you look at the companies, and especially product and services companies, they gravitate towards Kubernetes, especially if they need the kind of scale that you mentioned, basically thousands
Absolutely.
of containers and all that. Absolutely right.
Absolutely,
Yeah.
absolutely,
Hmm.
absolutely. And not only
Okay,
that, it
fantastic. So,
basically it gave them that freedom. No? Like if I have a
hmm.
Kubernetes-based my infrastructure solution, and then probably today I'm running it on Azure. Tomorrow, if it is really required, I may maybe I should be able to take it to, let's say, GCP or maybe AWS, and so on and so forth. So that kind of flexibility also is given once you have Kubernetes. Otherwise, you are married to a specific cloud platform forever, kind of thing.
Correct. Okay, great, great. So that tells us about the birth of Kubernetes, so to say.
Yeah, yeah.
Yeah. So if you want to kind of, if I wanted to, or someone wanted to visualize, what Kubernetes really contains, what are the bigger building blocks, of Kubernetes, can we describe those basically?
Sure, sure, sure. So, at a very simpler level, basically Kubernetes is nothing but I can say that it's like a managing a cluster. So typically, any complex application, it's going to have more than one node. In fact, you can't have really a Kubernetes solution if you have only one or two kind of machines which are there. So for Kubernetes, the most basic fundamental concept is a cluster. So you have a cluster of machines, or I may say that cluster of nodes, and those nodes together, they are giving us this solution of deployment actually. So let me just go a little bit detail into that. So basically, it's a collection of nodes, but all nodes are not alike. So there are, by a broad level, there are two types of node. One is a master node, or what we call it as a control plane kind of a node, and then other ones are the actual nodes, or I can say worker nodes, who are actually going to execute the task. So to put it in a simpler manner, I can say that control plane is also a node, but something which is a brain or a heart. And then the other nodes, the worker nodes, are where the whole muscle is there, which is actually going to carry out the workload, or do the heavy lifting of running of the applications, and so on and so forth. So you have these that way you have these two simple types of node. One is control, and the other one is actual set of nodes which is going to execute the application. So control plane, and then set of nodes. That's like a simplest architecture.
So the control node actually doesn't run anything, right? I mean, it
Absolutely,
controls.
absolutely,
That's it, right?
absolutely. It
And
simply controls.
okay.
So the entire
Hmm.
definition of cluster, what different kind of nodes are there, what is the capacity of that particular node, and then n number of other things which are required to manage all that set of nodes. everything is there as a part of that control plane. And then actual execution, actual running, or actual managing the workload is taken care by the worker nodes or the node machine. So one can say that, yeah, fine, control plane is a more lighter node as compared to the other set of nodes which are actually going to execute the applications.
Okay.
And then one may also have, like, of course, you can't have a single point of failure for this control plane node as well.
Also,
so maybe absolutely. So there also there is a solution, because otherwise, if control plane fails, then the whole thing may come down. Yeah.
yeah,
So
exactly.
that is
As good as
also
dead. So,
absolutely, absolutely. So we are not going to go into too much details of that, but at least at a very
Correct.
high level, this is what is really
This is
one can
what,
keep in mind. Fine, you have one control
Hmm.
plane, but also there is a way in which that can be replicated and ensured that the whole thing doesn't come down if your control plane goes down.
Correct. Okay.
Yeah,
But but of course the control plane probably is doing the key job of finding out that okay, I have n number of machines, to oversimplify all this, and I have so many things to run. So how do I balance this workload? Is that basically what it is doing?
absolutely, absolutely. In fact, it does lot of things. Like as we move ahead, I think we should be able to understand the
Okay,
more and more
perfect.
details of that. But I think
Perfect.
just to answer your question in a question, let me little bit go into details of this architecture part. See, it's not
Hmm.
just nodes and control plane. Uh,
Hmm.
if you apart from that node, what is there inside that node? Because node is nothing but a virtual or a physical machine, and on the
Yeah.
top of that, really there is something which really adds a value as far as Kubernetes is concerned. So what Kubernetes does is it has a concept called as a pod. So pod is a unit by which your application gets deployed. So pod is, I can say that it has one or more containers, and then Kubernetes is go whenever there is a need, then a new pod may get added on a node, and then it will start getting executed. So it's like on a node there are collection of pods. So it's not like just node. Inside nodes there are a collection of pods, and those pods contains containerized containers or containerized applications. So that's why every node will have set of pods which are running, and then within those pods, then you need container runtime engine. And also, because that particular node is going to communicate with other nodes, you need some kind of a network proxy which will help to communicate with the control plane. So that's the simplest kind of a view as far as the node is concerned.
Developers or DevOps team want to interact with it, then how do you go about it? How
Yeah,
do you
yeah,
do that?
yeah. Interesting. Yeah, yeah. So actually, once you have this cluster in place, then as you have mentioned, there are two types of people, like the developers, deployment people, and also the end users who are going to use this system. So typically, majority of the DevOps interaction is going to be with the control plane. And then therefore you have there are two ways. One is there is a command line interface, which is kubectl, which is there. Using that command line interface, DevOps people can talk with control plane. Or also there is a Kubernetes API. So using that API also one can interact with control plane. So that makes the life of DevOps engineer much easier. So either you can use command line or use APIs, and then that is used for the overall configuration, or basically telling Kubernetes about the new workload or new state in which DevOps people will like to take the whole cluster. On the other side, then there are users who are actually going to use them, and then for users, it is really an endpoint of an app. So they really even don't know that they are actually accessing an application which is running on Kubernetes. So
Not aware of Kubernetes in that
absolutely,
sense.
absolutely, absolutely.
Right.
So they will simply, if they're using a web app, then maybe they will have an URL, and then that URL internally may call different services of or APIs, which may be hosted across different services in Kubernetes. So internally, the entire load balancing or mapping the services to IPs and etc. Everything is done by Kubernetes inside. So end users doesn't really even know what they will actually know is fine. Like even if the load is high, then the overall performance is not really affected.